To start off, we'll cover some of the notable parts of the coding process. We struggled a bit on figuring out how to apply the program's stopping process as a subroutine, but eventually realized that giving the user a chance to press the stop button at the beginning of every loop was the better approach. Secondly, we originally had a subroutine to home the arm while the conveyor belt was moving at the same time, but we removed it because we had moved the bin to the other side and it was more efficient to do this.
The next few examples will show our flowchart's representation of the step-by-step process of our program. In the beginning of our flowchart, it says turn off red LED and turn off green LED. This is to ensure the lights are off before the start button is pressed. In this scenario, input 1 begins the program. If it is disabled, it will return back, redo this process once again. If input 1 is enabled, it will turn green light on and set the variable counter to equal 0. Continuing on, input 3 is the limit switch. If the limit switch wasn't there, the robot would not be able to detect whether or not a block is there in order to continue the program. After input 3 is enabled, the robot will wait for the operator to press input 1 in case of emergency. If input 1 is disabled, it will automatically end the entire program. Input 3 is also for the second and third loop to make sure that the arm moves when there is a block. And the second page, when it starts with turn off green LED and turn on red LED, all the way to drop block, this just continues the process of our program. In the drop block point, we change the pitch in order to place the block flat instead of an angle. In doing so, we make sure the block doesn't break. Next, in the lift up arm point, this inclusion to the flowchart is to prevent the gripper from hitting the block. If the conveyor belt started without this point, it would create an issue in our program's efficiency and safety protocols. By including to wait 5/10 of a second, it gives the operator time to turn the program completely off, even though there are blocks still present on the limit switch.
Some changes that we ended up making for the layout includes the bin, the start stop button, and input 3. Originally, we had the bin on the right side of the conveyor belt, but we decided to move it to the left side because the arm drops off the block towards the left side of the conveyor belt. By doing this, we increased the program's efficiency and speed. During the early process of the code, we were debating on whether adding a start and stop feature for the program. Once we decided on adding this, we had to add a start stop button in both list of parts and the layout. And finally, despite being in the list of parts, we didn't add an input 3 to the layout. Once we realized our mistake, we made sure to include a square and label it as input 3. When recording safety, we implemented different procedures to ensure our safety. Because we had soldered wires and breadboards, we moved all the electrical components into the corner farthest from us so we don't accidentally shock ourselves. We used 2 tables as a base so that we can distance ourselves from the parts as well as the parts from each other so they don't accidentally knock each other. We secured all the parts down onto the table so they don't accidentally move, tape for lighter items, and bolts for heavier items. Following OSHA safety guidelines, whenever we were using the robot, we'd always roll up our sleeves, tie our hair back, and put on safety glasses. When working with electricity, we'd always make sure to turn off the controller and any additional energy sources.
This part of our engineering notebook calculates the roll angle of our robot. To find the angle, I used the law of cosines and wrote down the equation first. I inputted the numbers of which we measured from our actual layout, and the answer to my equation was theta equals 43.76 degrees.